Welcome to this evening's TI Technology webinar hosted by Texas Instruments. For tonight, we're going to take a look at some essential TI-84 plus graphing calculator skills, specifically for statistics. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make my tough-to-teach, tough-to-learn concepts accessible to all of my students. I'm really excited to introduce our two panelists tonight, Diane Broberg and Chris True. Diane has been teaching high school mathematics for 25 years. She has worked on several writing teams for Texas Instruments and taught many summer workshops. Making math come alive for teachers and students keeps her creative. Outside of math, she is an avid runner. Diane, thanks so much for being with us.
I'm glad to be here tonight.
And Chris has been teaching AP Statistics and AP Calculus in Nebraska since 1998. He has served as an AP Statistics reader, table leader, and a member of the rubric team for the past 14 years. He's presented dozens of AP Statistics Summer Institutes, College Board workshops, AP annual conferences, national math and science teacher trainings, and student study sessions. He has also presented at several regional, national, and international Texas Instruments conferences. He has served as the Director of Mathematics Programs for the National Math and Science Initiative, and he currently teaches Calculus 2 and 3 at the University of Nebraska-Lincoln, where he also serves as a coach and mentor to the graduate teaching assistants who are teaching Calculus 1 and 2. Chris, thanks so much for being with us tonight.
All right, thank you, Mike. I'm glad to be here.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send questions to Diane or Chris using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. This session is being recorded, and as a reminder, we'll provide a link to the event certificate of attendance at the conclusion of the webinar. Once that recording is available in a few days, we'd love for you to follow along with your handheld or your software as opposed to trying to follow along tonight. I think that might be a little too difficult to do tonight on the fly, but certainly with the recording, you can pause and rewind and really go at your own pace with the recording. We hope you don't have any audio issues tonight, but in the event that you do, at the top of the WebEx menu, choose Communicate, and then choose Audio Broadcast. And if that doesn't fix things, in the participant window where your name is listed, in the lower left-hand corner, there's an icon that looks like a phone. And if you click that icon, it will allow you to connect the audio, not by the audio broadcast, but actually by calling in using a telephone, and that also should fix the problem. At this point, Chris is going to discuss our agenda.
Okay, so tonight's session is going to be split up into two parts. I'm going to lead a couple of activities. One activity is the Coke and Pepsi tasting contest that many of you have probably seen on AP Central. And then I also want to do a simulation. I'm thinking that most of you are maybe right around doing t-tests at this time of year, and how you kind of transition from going from a Z distribution to a T distribution when you're getting into inference. And if time allows, I want to go through sampling without repeats. There's some nice features on the TI-84CE that are not necessarily available on the TI-84 Silver, but there are some ways that you can kind of force the issue. And then Diane is going to pick up and talk about some of the essential skills that students are going to need when they go to take the AP exam, namely graphing and one-variable statistics, talking about probability distributions, discrete probability functions, and then getting into a little bit of inference towards the end. And so that's our agenda for tonight. And then at the end of this, so there will be some online resources available, and some goodies are going to be given away at the end of this, so you may want to stick around till the very end. Okay.
And Chris, I think you were wondering maybe who we had on board with us. So there's a poll that just appeared on the right side of your screen, and it should just be a yes/no. So do you teach AP Statistics? I'll give you 15 seconds to answer.
We want to get an idea who our audience is tonight, so if you would take a second to enter that, it would be great.
And Krista's last-minute answers are coming in about 10 seconds. I can share the results.
Great.
So the results should be appearing on the right side of your screen. Looks like we have about 18% that do, and then 53 that don't, and then a few that didn't answer.
Okay, all right, this is good to know. Although I think the things that we're going to go through tonight are going to apply to anybody who teaches any introductory statistics course. So I think you're at the right place tonight.
I agree. And at this point, Diane is going to discuss our expected outcomes.
So we're hoping that through the end of this, you'll come away with a couple of activities that Chris is going to do with you that you can use immediately in your classrooms, depending on where you are in your curriculum. And our other hope is that you're going to connect some essential 84 skills to questions. The questions we've chosen are questions from past AP exams, but they can be extended to lots of different questions in terms of the skills that I would think are essential for any person taking statistics. But we got a couple disclaimers for you. First of all, we are going to use the family of 84s. So question for you, how comfortable, what is your skill level with statistics and the TI-84? You can rank 1 as your low and 5 as your high. So we'll do the demonstrations on the 84 CE with the software we have, but the handouts that you'll get at the end of the webinar have additional notes and modifications made for the the rest of the family of the 84s. The other thing is to notice that what we're talking about in the handheld is the calculations that we can do, but for those of you who teach the AP exam, this is not the same as what students need to write. So it's really important that there's a distinction between the calculative skills and writing statistics correctly or in a way that can be read by the reader.
Thanks, Diane. And again, we're just finishing up the poll. In about 10 seconds, I'll be able to share the results. So those results should be broadcast on the right side of your screen.
So it looks like we almost have a pretty equal distribution of people who, in terms of their level of comfort with the 84.
Thanks so much, Diane. And Chris, it is all yours.
Okay. Let me get my desktop shared here. And I want to go through and talk about this Pepsi versus Coke tasting activity. And let me, first of all, talk about that I do this pretty early in the course. I want students to get an idea of what we're going to be doing throughout the course, and I want them to get a little bit of a flavor for doing some statistical inference early in the course, even though they don't have all the tools in place to do that, and that's where the TI software comes in kind of nice, or the handhelds work very nicely in class as well. So let me, some of you are probably familiar with this activity. If not, let me kind of quickly give you an overview of how it works in the classroom. All right, so what happens in this activity is we want to be able to determine students can tell the difference between two popular sodas, okay? I use Coke and Pepsi. I've also done this with Diet Coke and Diet Pepsi, and I know I've talked to other teachers who have done it with bottled water, cheap bottled water versus expensive bottled water. And so the goal is not to really to determine which one is which, but the students are going to be presented with 3 different cups in front of them. 2 of those cups are going to be filled with one kind of soda, and the third one's going to be filled with something else. And their job is to identify which one is the odd soda. All right, so a couple things that I'd like to draw out of this activity is I want the kids to kind of get an idea of, you know, the idea of experimental design and being able to control for variables and that sort of thing. And so the first thing I want to do is make sure that students don't see me fill up the cups, okay? Otherwise, it's a dead giveaway, and they're just going to say, oh, the one that you filled with Pepsi is different than the 2 Cokes, okay? We also want to control for temperature and carbonation. Those are 2 characteristics of soda that we're not necessarily trying to test for, but if they are different temperatures, the students are going to be able to tell which one's different by the temperature. So put them in the refrigerator next to each other, open them at the same time, and so forth. And then the other thing is we want to probably randomize the order in which the cups are presented. And so I don't want to always have Coke on the outside and Pepsi in the middle and so forth, so I want to randomize those. And so if you think about it, there's 6 different ways that you can arrange those 3 sodas where you've got 2 of one kind and 1 of the other. So one of the things I do first is, well, how do we decide which one of these to pick? All right, well, the activity on AP Central, they roll a die, all right? Well, we have a die kind of built into our calculator, and so I'm going to use the randint command on the calculator to do this. And so I'm going to flip over to my TI-84 software, and if you just go to Math and Probability and choose number 5, randint, and all I have to do is say I want to do randint 1, 6, close it, hit enter. Okay, this particular example, I got 6, right? On my PowerPoint, I got 2, right? And so I look up at 2, suppose I did get 2, and I see that that's Pepsi, Coke, Pepsi, so I fill this one up with Pepsi, this one is Coke, this one's Pepsi, and then I have the student taste all 3 of them and tell me which one's different, right? So pretty simple instructions here. And then as I'm doing this, each student is going to take the test, and I'm going to keep track of how many are correct and how many are incorrect. All right, so the logistics of this is if you can fill out several cups of soda in front of the kids before you get started and have all those ready, and I just put like 1/4 of an inch in each one of the cups so they can quickly kind of slug them down and just tell me, okay, B is different or so forth. All right, so let's say that we did all that and we got these results. Okay, I've got 29 kids in my class, and let's say, for example, 14 of them got it correct. All right, and so a couple questions that are going to come up then is, what's the proportion of students that chose correctly? Well, that's 14 out of 29, which is about 48.3%. All right, and another question is, if a student were blindly guessing, what proportion would he or she have guessed correctly? Some students are going to say 50-50 because you're either going to be right or wrong, but really you've got choices A, B, or C, and if you're blindly guessing, you're going to be right about 1 out of 3 times, so about 33%. All right, so it looks like preliminary results of this say, you know what, we got 48%, that's more than 33%, so yes, our class did do better. Okay, you've got to remember that this is like the 2nd or 3rd week of class, and I want to know what our proportion is significantly higher than blindly guessing to say that some students can tell the difference. So now they've got to kind of judge, is 48.3 a lot more than 33.3%? And at this point, I don't think that students really have any idea of how unusual or how common this might be. And so the goal here is to answer the question, is it possible for 29 students to blindly guess and do this well or better? The answer to that is always yes, everything's possible. But really what we're looking for is it likely to happen for a class to guess and do this well? All right, and this is kind of the whole idea behind calculating a p-value and making a decision based upon that p-value. Well, again, the kids don't have any way to find that, so we're going to lean on the calculator a little bit in order to do this. All right, so in the handout, I've got a table. And in this table, I'm going to simulate 50 classes of 29 students just blindly guessing, and I want to see how often we get 14 or more successes out of 29 tries. All right, so the simulation on this, I'm going to switch over to the software again and just kind of walk through as I do this. All right, first thing I'm going to do is clear this, and we're going to go to Stat, Edit, and I'm going to go over to List 1, and I'm going to clear List 1, and I'm going to populate this with the location of the odd soda. All right, so if you put the cursor at the top of list 1 and hit enter, notice that it's blinking down at the bottom of the screen and it's asking me for an input. So I want to put the location of the odd soda, which is going to be either location A, B, or C. Well, it doesn't understand A, B, C, but it does understand 1, 2, or 3. All right, so if I go over to math and then probability and choose number 5 again, and I want to pick numbers that are between 1 and 3, and I'd like to generate 29 of those, and then I hit enter. All right. And I see that list 1 has been populated with 29 numbers, and they're all 1s, 2s, and 3s. All right, then I'm going to go over to list 2, and I'm going to put in here the location or the guess of a student. All right, so the student's going to blindly guess 1, 2, or 3. Well, this is going to be exactly the same command. So if I go to math, probability again, number 5, and choose 1, 3, and I want to generate 29 of these. All right, so it's exactly the same command, but you'll notice that you get a different sequence of numbers. All right, so how did my students do? The first guy, the location was cup B, or cup number 2, and he guessed number 3. He got that wrong. Number 2 got it wrong. Number 3 got it correct, and so did number 4, and so on. So what I want to do basically is go through this list and compare the location to the guess and see how often they got it correct. All right, so I tell my students, you know, we could go through this list and do that by hand, but these calculators cost $100 or more, so we're going to have the calculators to do that. Should be smart enough to be able to do that for us. So I'm going to go over to list 3, and in list 3, I'm going to basically ask the calculator, is the number in list 1 the same as the number in list 2? So at the top of list 3, I hit enter. It's blinking down here at the bottom of the screen, and I'm going to say second 1 for list 1. And then the equal sign is under second, and it's the test menu, which is the math key on the calculator. And I want to pick equal to. And then is that equal to list 2? All right, when I hit enter, most of my students will be able to tell what's going on as I do this. All right, so you notice that sometimes I get zeros, sometimes I get 1s, and it doesn't take very long to realize that, hey, this is a Boolean operation, and it's telling me 0 if it's wrong, and if it's correct, it's 1. And now what I'd like to be able to do is go through and count how many 1s are in list 3. All right, well, there's a slick way to do that. If you go back to the home screen, you can just say second stat math, and then do a sum, number 5, of list 3. Okay, and when I hit enter, that number 11 that I see represents that I had 11 students out of 29 blindly guessed and got it correct. All right, at this point, I like my students to kind of understand really what this number represents, and is it something that we'd expect to have happen. Okay, if I'm blindly guessing and I have a 1/3 chance of guessing correctly, I would guess that about 1/3 of the time I'm going to be right, and 1/3 of 29 is somewhere around 9 or 10. So 11 is, I would say, not unusual. Okay, so if we go back to our table, right, on our table, I would put in the top entry, trial number 1, we got 1 correct. I'm sorry, we got 11 correct. All right, so now I've got some more work to do. Okay, I've got 1 trial done. I've got 49 times I got to do this again. All right, so this is a nice way to do it, but it is kind of time consuming. And so, you know what, there's got to be a more efficient way to do this, and guess what? Luckily there is. All right, so here's the idea. I'm going to flip back to the software again, and at this point, it may be beneficial. I know a lot of people like to use the math print, but I'm going to go back to the classic view, and if you just hit the and toggle over here to the classic view and highlight it, I think you'll see why I want to do that here in a minute. So go to the classic view and then get out of here. All right, so we could populate those lists from the home screen as well, and it's exactly the same command. It's math, probability, and it's number 5, randint 1, 3, 29. Okay, close the parenthesis, and I want to store these in list 1. Okay, now I might be tempted to hit enter here, but I'd like to be able to do a handful of things in one shot. Okay, I learned this at a workshop somewhere that if you have ever written a program for the calculator, the commands in a program are separated by colons. And so we're basically just going to write a short program here.
Hey, Chris, you want to go back and make it an L1. You didn't quite get your second. I just don't want you to get through the whole command.
Thank you so much. Okay, L1, not 1. Okay, and then I want to hit alpha, and then the decimal place will give me the colon. All right, so this is going to populate list 1 with the location of the odd soda, and then I want to put the guesses in list 2, like I did from the list menu, and go down to number 5. We're going to put in the same command again, 1, 3, 29. Close the parenthesis, store these in second 2. All right? Put a colon at the end of that. Okay, then once I got those 2 lists populated, the next thing I did was I said, is list 1 equal to list 2? And I stored those results, equal to list 2, and I stored those results in list 3. Okay, and then another colon, and then second stat math, and I want to do a sum of the numbers that are in list 3. All right, close the parenthesis and hit enter. All right, so this just simulates exactly what I did in those lists by putting the commands at the top of the list and so on. This time I got 7 out of 29 guessed correctly. All right, so now I've got 2 trials done, and I could put a 7 in my next entry for trial number 2. Now the beauty of this is all I got to do is hit enter several times until I've got all 50 of my results marked in the table. All right, so you can get an idea if you hit enter a couple of times, you should see these numbers bounce around 9 or 10. Sometimes they go a little high, sometimes they go a little low, and so forth. Okay, I noticed that I haven't seen a 14 yet, so kind of keep that in mind. All right, so now if I flip back here to the PowerPoint, and basically these slides just tell me what I just did, what proportion of the accumulations did as well or better than our class did in choosing the different soda. All right, so now remember that our class got 14. All right, and I just simulated 50 classes doing exactly what we did, and I'll tell you that when you do this activity, I would expect to get maybe 2 or 3 out of 50, which ends up being about 4 to 6%. Okay, so it doesn't happen very often, and when you've got all the kids in your class doing this, you are going to zero in pretty close to what that probability happens to be. All right, and so now I'm going to use this number to describe whether the proportion of correct choices by our class was significantly higher than blindly guessing. So what I'd like the kids to get out of this activity is, you know what, I'm going to say that at this point, most students are going to say if something only happens from 4 to 6% of the time, that's a pretty unusual occurrence. And I'd like them to get the idea of kind of interpreting a p-value at this point as well. And they've got a nice introduction to doing some kind of statistical inference without having all of the tools in place to do that. Right? One of the other nice things about doing this activity early in the year is you get a couple of opportunities to pull it back out. When you get to studying the binomial distribution, you can actually calculate this probability using a binomial distribution and not have to do this with a simulation. And then, of course, when you get to doing one proportion z-tests, okay, you've got to be a little bit careful on this one because the conditions are not quite satisfied. 1/3 of 29 is not quite 10. And so I know that most textbooks say that that condition is that the NP and NQ have to be at least 10. So you might want to think ahead on this and maybe get 30 or more students in your activity when you first do it. All right, so that's the extensions. Again, I just mentioned that, forgot to slide through those. All right, I'm not watching the chat, but were there any questions that popped up there, Michael or Diane, that should probably be addressed at this point?
No, it looks good.
Okay, very good. Again, Michael mentioned that I'm going through this pretty quickly, that you may or may not have your handheld in front of you and trying to keep up with this, but I would certainly invite you to come back and get a copy of the recording where you can run through it and pause it, repeat it, and do it at your own leisure. Okay, the next activity I want to work through is why we would want to talk about a t-distribution, right? And sliding from the central limit theorem to getting into the t-statistic, right? And so in this activity, I'm going to suppose that we've got a population of IQ scores, and those IQ scores are approximately normal with a mean of 100 standard deviation of 15. Right, and then according to the central limit theorem, the sampling distribution of x bar is known to be approximately normal with a mean of 100 and standard deviation of 15 divided by the square root of n. All right, so what I want to do is I'd like to sample from this population and calculate the z-score associated with that sample. All right, so I'm going to flip over here quick to the 84 again, and let me clear this and think about the process of randomly sampling from this population. Right, so the command is math and probability, and we do spend a lot of time using the randint, but there's also this nice command called randnorm, right? And randnorm is going to ask me for the mean, and it's going to ask me for the standard deviation, and it's going to ask me for how many of these I want. Okay, and if I hit enter here, I'm going to end up with this generating 4 numbers that are randomly selected from this normal population. I'd expect these numbers to be somewhat close to 100. Right, I'm going to store these in list 1. Right, and then I'm going to go to alpha and the decimal again, and then I'm going to have the calculator display this z-score. Let's see, if I switch this back to the math view, and screw it up if I've got this started this way?
I think you'll be okay.
Okay, let me do that. Switch back to math print. Okay, and enter. Okay, it looks like it's over. Okay, so math, probability, random norm. Okay, 100, 15 was the standard deviation, and I want to pick 4 of these people, and I want to store this in list 1. All right, and then alpha decimal. Okay, and then I want to calculate the z-score. All right, so in order to get that, is it under math and fraction, right? Under math fraction. All right, so now I've got this nice bar, and the z-score is going to be to take the mean of the sample, which is second stat math. Mean is number 3. I want the mean of list 1. I'm going to subtract the mean of the population, which was 100. And then I'm going to divide by the standard deviation, which was 15, divided by, and I'm going to put the square root of 4 in here instead of just putting 2. Okay. All right, and then when I hit enter, I'm going to get a z-score for these guys, or these students. All right, and so notice that this z-score is negative, and it's fairly close to 0. And if I go back and I look at these 4 people, I see that they're relatively normally distributed in list 1. There was really nobody that was unusual here, and I would expect to get a z-score that's fairly close to 0. All right, so if students hit enter several times here, what I generally do in my class is I say, hit enter a bunch of times, and if you get a number that's bigger than 3 or less than -3, bring your calculator up, and I want to take a look at the sample that you got. Okay, but I think what we'd expect to see here is these numbers are going to bounce between like -3 and +3. All right, which I think is something we're not too surprised at according to what we already know about the central limit theorem. All right, but now what we're proposing is we're proposing that if I don't know what the population standard deviation is, which is typically something we don't know, it seems like the normal thing to do would be to substitute in the standard deviation of the sample. Right, and so if I do that, it's fairly easy to do this on the calculator. I'm just going to go up here and steal this command again, and I'm going to substitute in here instead of the 15, I'm going to get rid of that 15, and I'm going to replace it with the standard deviation of the sample, right, which is, I'm going to insert second stat math. Standard deviation is number 7. That's the sample standard deviation, and I want the standard deviation of those numbers that I had in list 1. Okay, I want to see what's going to happen as I hit enter several times. All right, I think we would kind of expect that these numbers are going to bounce around 0 again, and they may or may not quickly go to some numbers that are relatively large or relatively small. All right, there's a 3.04. Let me tell you that I was kind of messing around with this, and if I take 2 and store it in RAND, okay, doing this is going to seed my calculator in such a way that I know what the next results are going to be. So if I go up here and I steal this command again, and I hit enter, I think it's twice, okay, the second time I hit enter, I get this relatively large test statistic. So what I want to ask at this point is, tell me about this sample that I got. You know, these kids must be from, you know, some school that they're just doing a fantastic job of teaching the kids. But what I want to look at is, you know what, I got an opportunity to see that. And I'm going to go up here to Stat, Edit, and I see that these 4 students' IQs, remember the standard deviation was 15. All of these kids are within 1 standard deviation of the mean. But the question, I guess, is then, well, how come we got such an inflated test statistic? And if we got such an inflated test statistic, I would hope that at least some of my students would look at these numbers and say, hey, you know what, they're pretty close together. That standard deviation is probably not 15. That standard deviation is probably something fairly small. Right? And so when we go back here to this test statistic, okay, if we substitute in S here, this is the example I just took, okay, notice that the standard deviation is somewhere around 4.6-ish, which is nowhere close to 15, and we get this unusually inflated test statistic, which is going to happen, I would not say more often than not, but it's not going to be unusual for it to happen. Right? And so this kind of generates the whole idea of, hey, we got to come up with a new kind of a test statistic, which our friend Gossett at the I guess brewery worked on, you know, over 100 years ago. It's kind of neat to show kids this also, that this is some mathematics that was discovered within, you know, 100 years or so, is relatively new mathematics. Okay, I want to make sure that Diane has enough time to get through her stuff, so I'm going to forego the sampling without repeats and turn this over to Diane. So let me switch this over, Diane, and you'll be taking over. Okay, make presenter. Okay, Diane, you should have control.
Okay, so now we're going to think about this concept of using the TI-84 as a tool. And when I talk to students in class, we have this discussion, we actually had it again today in class, that your calculator is only as good as you are. And so sometimes they get frustrated because it's not doing what they'd like it to do. But in the same respect, my statement to them is, you know, you got to keep learning it, you got to keep using it. It's got tons of features, and if the only thing that you can do is, you know, add 3 plus 4 on it, then you're missing out some of what it can do. So typical question from statistics is a group of data. So I found a group of data here. It's talking about what's happening before training and what's happening after training. And so one of the things we often begin statistics with is this question is describe the distribution. And there's lots of different ways to describe the distribution, but some of the things we're very interested in are the shape, center, and the spread. So the question becomes is how can we have students look at the shape, center, and spread?
Hey, Diane.
Yeah?
Can you do me a favor and share your desktop?
Did I not do it?
Not yet.
Uh-oh. Sorry.
That's
I got too excited. So what were you seeing then?
Just a WebEx screen.
Oh, how's that? Is this better?
That looks great.
Oh, okay. So let's see now. So now you see my screen too, and you can see the data that I'm going to use. So all of these, the questions that I'm using tonight, all of that stuff is in the handout that you'll get at the end. So don't try to enter this data with me. It's going to take you too long to do it. And so, but back to where I was, is we want to look at this concept of what does the data look like. So the first thing I did in doing it, I went to my statistics, and long before I saw you, I entered the data of before and after. And so my first question was, hey, what does this data look like? So to look at that, we go to second and stat plot. We are going to turn on our stat plots, which I did. I'm interested in this time, I think, in looking at a box plot, because I think a box plot for many students allows us to compare the data. I chose my X list. Now, this is something that's new for many people, is the list I chose I actually named, and I'll show you how to do that in just a minute. I actually like lists that are named because then I know what I'm working with instead of list L1 and L2, because sometimes I forget. So to do that, or to get this X list here, I hit second in list. It'll give me the names of all my lists. If I scroll down or if I hit the number 9, I'll get the before that I was hoping to get in there. And then there's my graph. And if I do that now, I would get one graph on my graph. But what I'm interested in is actually comparing things. So I'd like to go up. I'd like to look at plot 2. And I'm sorry, I cheated a little bit ahead of time. And I turned plot 2 on. This time, again, it is the after. And so I'm interested in looking at the two together. So to get my best window, if I hit zoom, and number 9, which stands for stat, what that does is it takes all the statistics you've put in it and it makes the best possible window. So if I hit number 9 right now, I get a pretty nice comparison. I get the two graphs back to back. And so we often want students to graph them on the same scale. I have them on the same scale here, and we can have those discussions as we describe our shape, center, and spread. I like this because we can look at it, we can say, hey, they definitely don't have the same center. We can look at it and we can see, hey, the spread is about the same. And we can have this discussion about the shape of the two distributions and what do they look like, or what can we predict about the histogram based on the box plot. And so it's a way to begin to look at data. And so looking at the graphs is really good, and I always start with that. And the second thing I say to students, because they really don't always like it just looking at stuff, they would like numbers to go with it. And so as Chris kind of did with you, if we go back and sometimes we'll actually want to calculate those numbers. And so if we look at statistics and we move over to calculate, we can calculate our one variable statistics. I can choose what list I'd like it to be in. This time I'd like it to be in list. Let's see, I'm going to hit second and list to get my names of them. I would like it to be, we'll start with the before, so I'll go down to number 9. My frequency list is nothing, so I'd actually like it to be 1. So I'm going to put the number 1 in there. And then if I hit enter, and oops, what happened here? We'll try again. See what it didn't like. Why is it not liking this, Chris?
Go to number 2 again.
Let's try again. We'll try it again. Stat. I would like to calculate one variable statistics. It typically works. I would like it to be. My frequently list, I'd like to be 1. Or none. Whoops, let's try again. And then I'm just going to give up. Let's clear it.
Hit the down arrow instead of enter.
Yeah, there we go. And there we calculate. We have our mean, we have our standard deviation, we have our number of values, we have an X-min, we've got our Q1, we've got all the values that come from our box plot. And so I find that really helpful in terms of having students then look at numbers and compare, because they like to put graphs together with numbers. They're much more comfortable, I find they're much more comfortable with numbers than they do happen to be with letters. But now if I go back to this question for just a minute, and the question's got 2 things of data here. And so there could be several different questions. If I don't actually read what the question is, one of the things we often like to do if we're talking before and after, now I know it's not this question here specifically, but before and after, we're sometimes looking at a matched pairs design. And with the matched pairs design, what we're most interested in is we're interested in the difference. And so, again, I often have students that would like to calculate these, and they're pretty good at subtraction, but our calculator can do the same thing for us. So if we go back to stat, and we go to edit, we would like to create the differences. And this is what Chris did before of you. If you go up to the top, what we'd like to do is we'd like to see if after beats before. So I'm going to use second and list. I am going to go down to number 7. I am going to then subtract my before. When I hit enter, it will populate those things. one of the first things we have students do when we're talking about a t-test, if it's a matched pairs design, is after they come up with their hypotheses, they need to decide if the data is normal. So again, we have to graph the data. And if we go back to stat plot and I will use, let's see, I'll take this one here. We will change it from before. We will change our list to the differences. So I'm going to have to go down. I could have gone up also. I'm going to hit enter. I am going to go back up, even though I'm done with what I want here. I am going to go to plot 2, and I'm going to turn it off. And then I'm going to hit, I have one graph, so I'm going to hit zoom and 9. And there's my graph. One thing I'm looking for in terms of, are there outliers? Outliers tell me that it is not normal. The second way to look at it, and this is what I keep trying to convince my students, they all want to do a histogram, and I keep trying to convince them that histogram is not going to help them, but the other graph that we do like is a normal probability plot. And if I chose that one for us, we are going to hit zoom and 9 again, and we can look and say, hey, is it approximately a straight line? If it's approximately a straight line, we know that our data is approximately normal. I think it's very important for students to understand the concept that it's approximately normal and not exactly normal, and that's the condition we needed to do a z-test or a t-test.
Hey, Diane.
Yeah?
We had a question from Jane a few seconds ago about whether you always use the modified box plot. Can you talk about that?
Yeah, I do like the modified box plot, and the reason I like the modified box plot is that it shows the outliers. And a real distinction for students in terms of determining if data is normal or not normal is based on that concept of the outliers. And so with the modified box plot, it shows the outliers. And so when we're getting towards this concept of testing and looking at normal data, I do think it's important to use the modified box plot. At the beginning of the year, when I first start doing box plots, I don't do that, but when I get closer to testing, I do. So I hope that helps. If we do just a little bit more with this question, I want to do one last thing with it, is I want to look at this concept of a t-test and how the calculator can help us with a t-test. If after we've checked our conditions, so we know our data is approximately normal, then our next step is actually to do that. So if we hit stat and we move to the right and we get tests, we are interested in a t-test. There are two ways we can input the data. We can input it as data, or if we are just given statistics, we could input that also. We have the data, so we're going to use that. I'm going to treat this as if I was testing this as a matched pairs, and is there a difference between before and after? So we're going to use that as our null hypothesis is 0. In this case, I had the list, as I put it before, it's that list that is difference. Our frequency is 1. Our null hypothesis, well, we hope that before helps us, and so, or sorry, after helps us. Our training helped us to answer more questions correctly. And so if that's true, then our null hypothesis is going to, our alternative hypothesis is going to be greater than 0. So now I'd like to calculate it. If I hit enter here, there is my statistics. And as I tell my students that my calculator can do the statistics, it can do the graph, and it can do the statistics, and now it's their job to interpret them. And that's the most important part of statistics, is to be able to interpret them. So they need to understand what does the test statistic tell us, and what does the p-value give us. But the information that they need is readily available there. So let's move on to a second topic that we might encounter in our classes. Here's my solutions. I'm going to go on there. Is this concept of distributions. We have normal distributions. We do binomial distributions and geometric distributions. I'm going to start with this question of what is the 70th percentile of the distribution of stopping distance. If I happen to know the average is 125 and the standard deviation is 6.5. So we all have tables that can get us, so we can use to find our 70th percentile, but the calculator can get us there. So I'm going to toggle back to my calculator. I am going to clear what I have. I am going to this time go to distributions, Sometimes I'm challenged to find it because it's in little blue letters right there, but if I hit second and distributions, I have all these options. I'm interested in the 70th percentile, which means I'd like my inverse norm. This is one reason that I like the math print, because the math print will walk us through the inputs that we need. If you're using classic print, you have parentheses, and in your parentheses, you have to either know what you're using or you can use the plus key to find them. So in this case, we have an area that is 70%. We had a mean that was 125. And we had a standard deviation that was 6.5. This is something that's actually new for me, seeing the tail, the center, and the right. I'm used to this concept that it is always from the left, so therefore I always teach my students we continue from the left. But now I'm going to paste that in. I paste that in. I'm going to hit enter, and it tells me that my 70th percentile is 128.4 feet. I find the inverse norm is something we do quite a bit of in terms of when we're looking back and forth with looking at our normal distributions. Second part of this question happened to turn out to be, what is the probability that at least 2 cars out of 5 will be able to stop in a distance that is greater than the distance we calculated, that 128.4 feet. So important thing for students to understand and for us all to understand is that we are looking for an at least probability, which means I want to be greater than or equal to 2. That, in terms of mathematics, is the same as 1 minus the probability that x is less than 2. And because we're talking about a binomial distribution, where when x is less than 2, it actually means that x is less than or equal to 1. That's an important thing when using the calculator, especially the 84. So if we toggle back and look at how we're going to do this, we're going to again go back to our distributions. We are going to go down this time to a binomial. Now you'll notice you don't see binomial. So either we scroll down or we scroll up. So I will scroll up in this case. I'm going to scroll up and I would like to do a binomial CDF. This is a cumulative function. So therefore it's going to add everything. And in this case it adds everything from my left on up. And that's why it was important that we make the distinction that the probability that x is greater than or equal to 2 is the same as 1 minus the probability that x is less than 2. So the problem said we had 5 trials. The question said I wanted my stopping distance to be more than 128.4, which means I'm not in the 70th percentile, was below that, so that means my p has to be 0.3. My x value, this is the value that I'm counting up to, so therefore I'm counting up to 1, and I'd like to paste it in and see what I end up with. Hit enter. It is that. So now I'd like the answer, so I need 1 minus. If I use my little up arrow, it'll grab that answer for me, paste it in there, and I get the probability is 47.18%. The last part of this question is this question. It says, what is the probability that a randomly selected sample, this time of 5 cars, have a mean stopping distance of at least 30 feet? And when I think about this and when I do it with students, I frequently draw the picture. And our calculator has the ability to draw the picture. So we can use that as, I use this part here as a teaching tool when I'm working through things in the beginning of the year. When we get closer and closer to the AP exam, I do less time showing it again, and we actually use it. So for this one, we will go back again to our distributions. We will do a normal CDF this time. My lower bound in this case, it told me I was starting at 130, so my lower bound is 130. My upper bound is a big number. My students put a whole variety of zeros in. I have a mean of 125. And my standard deviation, I really do like this. I can type it in as 6.5 divided by the square root of 5. And my parentheses, paste it in. For those of you who are used to the classic print, there you get the classic print. You see the difference between the math print and the classic print. So the question is it likely that 5 cars are going to have a stopping distance of at least 130? The answer is no to that one. Okay, so let me go on here. When you get the handout, you'll see that there are screenshots in there that lead you through a lot of this. I'm going to skip this one for now because it's one that comes up. It's kind of a cool little way to do it, but I'm going to skip it and let you look at it later. Because I want to do a little bit with inferential statistics, because I have found that in my years of doing workshops and things, I think sometimes this is where teachers tend to use it the least, and I think it actually can be the most helpful for students in terms of calculations, because I think they are challenged at times. So this question says, it says find a confidence interval. We know that we have 45% of the people who are eligible to receive a vaccine is what the U.S. believes. In our studies, 978 of the 2,350 people who could signed up to do it. It says construct a 99% confidence interval and then use that to validate, hey, is 45% really good, or does the United States government not have an idea here? So let's see what we can do here, use our calculator to do so. We are going to look at stats. We, again, even though it's not a test, we are going to go over to our test menu. And we are looking for an interval this time. We are looking for a 1 proportion z-interval. We got to scroll down here. We could scroll up. There we go. We got a 1 proportion z-interval. I'm going to hit enter. It said to me, what was my x? Well, my x from the question was 978. My n was 2,350, and I typed in ahead of time my confidence interval was 0.99. I calculate, and what does it give me? It gives me my lower bound, it gives me my upper bound, and it gives me my p-hat. And so this allows students to actually see the calculations. They can look and say, hey, is my 45%? They would come to the conclusion that the sample that they had does not accurately reflect what the U.S. government believed was happening. Second question that would allow us to use something similar. This time it's a test. This is a 2 proportion z-test. It tells me that my significance level is 0.5. This one tells me at the end of 6 years, I had 15 people who took the low-dose aspirin, developed colon cancer, and 26 of the people who took the placebo developed colon cancer. We had 1,000 volunteers who were sent to the 2 different groups. So let's see what we can do. We decided this time we were doing a test. So I'm going to hit stats again, and I'm going to go over to tests. It is a 2 proportion z-test. I'm going to hit enter. I knew that I had 15 people. My total N was 500. In my second, my control group had 26 that developed it. I had a total again of 500. I am trying to figure out, did my proportion change over the 2? So actually I would like my null hypothesis to be less than, because this was my control group. I would like to calculate my statistic. This, again, it allows students to see the test statistic, the z. It allows them to see the p-value, and it allows to see the proportions that they need in using the calculations and to writing correct work when they're looking at the AP exam in May. Unfortunately, I think I have about hit the time I had. I had one more question to look at with you. I'm going to let you look at it on your own. It is the chi-square test of homogeneity. And the calculator does a really nice job with it. It uses matrices to do it. It will calculate your expected matrix given your observed one. So I'm going to turn it back here to to Mike and see if there's questions you have for us.
Thanks so much, Diane. As Diane just mentioned, if you do have any last-minute questions, please try to get those asked. I know in the last couple minutes here, Chris and Diane will try to get those questions answered. I'd like to share a resource that's available on our website, education.ti.com. I noticed we had a good portion of you on tonight are here for the first time, so welcome. I hope that you've enjoyed what you saw tonight. And if you're looking for more professional development in this format, if you look under the Professional Development tab on our website and move down to Webinars and Tutorials, you'll see some great options like live webinars or on-demand webinars, or lastly, some tutorials that you could use for your technology. Mm-hmm. If you check on the live webinars tab, you can see all the webinars that we have upcoming for the remainder of the spring. And so some of those might be of interest to you. If they are, that's great. You can register for free. And if you can't make it for one reason or another, the nice thing is once you register, you automatically get a follow-up email. If you don't attend, a follow-up email that says, we're sorry you missed it, but here's a link to the recording, the documents, and the certificate. So you get the complete package, whether you can attend or not. So please feel free to visit our website to learn more about some of our great webinars. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback really guides us as we plan future online events, and we really hope you'll share your thoughts in the post-webinar survey. We're really excited that I believe coming next week, we're going to have a list of all the locations and workshop titles of our summer TCUBE professional development workshops, and those are going to be spread across the United States. There should be, I believe, over 50 workshops available, and what's nice is they focus on all sorts of different things. So maybe you're looking to learn more about statistics or the 84 or some of our other technology or maybe other pedagogy or other content. So we have workshops, again, spread across the United States that focus on just those specific things. So please feel free to check out our website in, I believe, the coming weeks here. We will have everything posted and we'll be live. We mentioned earlier, though, for one lucky winner tonight, we're going to be giving away a TCUBE Summer Workshop registration. And tonight's lucky winner is Satina Dooley. So to Satina, congratulations. We'll be in touch over email in the coming days to give you a little more information, but we really hope to see you as well as everyone else attending a TCUBE Summer Workshop. Please feel free to continue the conversation that was started tonight on any of the major social media outlets. To receive a certificate of attendance, go ahead and click that link in the chat window. Also listed is a link for the documents that were shared tonight by Chris and Diane. And if those links happen to not be working for one reason or another, don't worry. You'll automatically, again, get a follow-up email in a couple days, and that follow-up email will have a link to the recording, as well as a link to the certificate, and then a link to the documents. And if you happen to be watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. If you're in the need of any post-webinar follow-up, we'd love to hear from you. Please give us a call at 1-800-TI-CARES or send us an email at ti-cares@ti.com. So I'm going to join a few other people in the chat window that are thanking Chris and Diane. So thanks so much, guys. I really appreciate everything you shared tonight.
It was a pleasure. I enjoyed it quite a bit.
Yeah, same here. This was a lot of fun.
Again, thanks so much, everyone, and we hope to see you back online next week. Have a great night.